Hello everyone, this is Dr. Adil. Before we begin, I want you to imagine something for a moment. Think about a robot we see in our real life, robots that can move on their own, avoid obstacles, help in surgeries, explore dangerous places, or even fly as a drone. These robots are not just machines, they are systems that can sense, think, and act. And that ability is exactly what makes robotics such an exciting and rapidly growing field today. In our everyday world, we already rely on robots more than we realize. Uh, when your phone adjusts the screen orientation, when a car uses sensors to help a driver stay on the lane, um, when a factory uses robotic arms to build products with perfect accuracy, all of these depends on the same idea we are going to explore today. So the concepts you learn here are not just theoretical, and they are happening all around us. What makes robotics truly powerful is the combination of sensing, action, and intelligence. A robot that cannot sense is blind, actually. A robot that cannot act is useless. And a robot without intelligence is simply a programmed tool. But when all these come together, we get machines that can make decisions, respond to the environment, and adapt to challenges. In this talk, we'll cover the foundation behind these abilities, how sensors allow robots to understand their surroundings, how actuators give them the power to move and interact, and how technologies like MEMS and AI help become smarter, smaller, faster, and more autonomous. My goal today is simply to give you a clear understanding of how robots make sense um, of the world and how they turn that information into real action. Whether you are completely new to this or already have some background, I want you to walk away with a stronger foundation and greater excitement for what lies ahead. So, as we begin, keep an open mind. The ideas may seem small, like a tiny sensor or simple decision, but together they build the entire world of robotics. And I hope that by the end of this session, you will feel inspired and explore even deeper into this amazing field. Those convert physical quantities into electrical signals like light, distance, motion, and temperature. Similarly, actuators are devices that converts electrical commands into physical motion. Those motions can be in rotation or moving something upward and downward or left and right or some vibrations. Sensors are important because a robot cannot operate safely unless it can observe or understand its environment, whether it's avoiding obstacles, recognizing objects, or understanding its own position. All of that starts with sensing. Sensors are also key to autonomy. Robots rely on them for mapping, localization, uh, and obstacle detection. And this importance isn't limited to one field. Sensors are used in industrial robots, medical robots, service robots, and drones, making them fundamental to almost every robotic system we use today. Sensor fusion combines data from multiple sensors to give a robot or any machine a much clearer and more reliable understanding of its environment. Cameras, radar, lidar, and ultrasound um, each have strengths and weaknesses. So fusing them reduces noise and improves accuracy. Self-driving car, which typically uses 20 to 30 sensors, including more than six cameras, multiple radars, couple of lidars, and multiple ultrasonic sensors. Together, these enable safe navigation, obstacle detection, and real-time decision making. Instead of following a fixed set of instructions, uh, artificial intelligence-based systems recognize pattern, improve their experience, and automate tasks that would normally require human thinking. That's why AI is now used everywhere, from healthcare to finance to robotics, and everyday app we use in our phone. To achieve intelligent sensing, AI is integrated. Instead of just reading raw sensor values, AI helps interpret complex data, whether it's image, motion pattern, or environmental signals. These systems also adapt their sensing based on changing conditions, which makes the robot more reliable in real-world environment. Combined with closed-loop system, the robot can continuously monitor its action and correct itself in real time. Typical example include anomaly detection, spotting when something is wrong, and path planning, where the robot figures out the safest and or most efficient route to follow. And such decisions are very important. Either those are for cars, aircraft, or any processing industry, or in any medical related equipment. Now let's see electromechanical systems. Electromechanical systems combine electrical electronic components with mechanical parts to create some useful motion. When electrical signal is given, electromechanical system converts them into mechanical movement, like rotation, pushing, or lifting. In some cases, they also work in reverse. So like turning mechanical motion into electrical signals. This idea forms the foundation of many robotic components, especially motors, actuators, and sensors that rely on both electrical control and mechanical motion. Here's an example we see in our daily life, that is power window of a car, in which through a button we command a motor that moves the window up and down. And here's another example. There's a robotic arm in an industry where we can see some sensors and motors as an actuator to perform different tasks like pick and drop, or spraying, or painting different components of different devices maybe. Here's another example in which we see temperature maintenance system, where there's a temperature sensor that sends the data to a computer, like single board computer, Arduino in this case, and based on different commands and programming, that computer controls turning the fan on and off, or uh, controlling its speed. Here's another example, that is obstacle avoidance system, in which ultrasonic sensor sends some data after sensing to the computer, and the computer makes some decisions to stop or move the wheel in which direction and at which speed. Micro electromechanical systems, or MEMS. Those are tiny electromechanical devices built directly on a silicon chip. They combine sensors, actuators, and electronics at a microscopic level. Just imagine the size of a microphone, even smaller, than the thickness of a human hair. If we see their importance, they are extremely small, consume very little power, operate with higher precision, and respond very quickly. Um, and because they are made using the same processes as integrated circuit, they become very inexpensive when manufactured at large uh, scale or large quantities. Uh, there are some electromechanical systems which are built at nanoscale level, and those are called nano electromechanical systems or NEMS. If we compare MEMS and NEMS, then NEMS provide better sensitivity, faster response, and MEMS offer better reliability, easier fabrication. Now let us understand where we can see MEMS-based systems in our daily life. Accelerometer measures linear acceleration and is used in robots, drones, and even smartphones for detecting movements and orientation. MEMS gyroscope measures rotation, which is essential for drones, balancing robots, and navigation systems. MEMS pressure sensors used in microscopic diaphragms and are widely used in medical devices, even automobiles and robots to measure air or fluid pressure. Are ultra small, high sensitivity audio sensors found in phones, wearables, and robots for voice detection. And finally, MEMS micro actuators are such devices which use electrostatic or thermal mechanics to create tiny movements, enabling precision control in optical system and micro robots. Now let's see the importance of MEMS based devices. MEMS devices play a really important role in many robotic applications. For example, in autonomous navigation, MEMS accelerometers and gyroscopes I already mentioned before help robots stabilize, balance, and understand their orientation. In medical robotics, MEMS pressure sensors and micro actuators enable extremely precise and minimally invasive uh, surgical movements. Um, Plus, in industrial application automation, um, MEMS sensors support quality control by monitoring vibration, motion, pressure with very high accuracy. Moreover, in wearable robotics or prosthetics, MEMS inertial sensors makes movement smoother, more natural, and more responsive to the user of that prosthetics. Since the purpose of this video is uh, to create a foundation to understand the about the sensors and actuation in especially in the field of robots, let's see before closing what are the key takeaways from this video. First, sensors give robots the ability to see and understand their surroundings. They are the foundation of perception. After the processor processes the sensed data, they are able to take some decision based on the algorithm or the purpose we are making that system. and the actuators take those decisions and convert them into real physical action, and such actions together make make it happen that what we are actually uh, wanting that robot or a system to do. We also saw how sensor fusion, like combining data from different sensors, can improve a robot's accuracy and stability by combining data uh, and processing accordingly. The fusion of data coming from different sensors uh, has so much importance that overall noise is reduced, overall sensitivity is increased, or stability of the system is improved significantly actually. After that, we saw MEMS technology um, allows powerful sensors and actuators to be miniaturized and embedded into compact robotic system. Since such systems are all integrated into a single chip, the overall size, overall cost, if manufactured at mass level, and overall performance, speed, response time, everything improves a lot. And finally, artificial intelligence, which is being used in almost every field in today's world. So artificial intelligence is also is being used in the field of robots and industry. AI ties everything together by giving robots the ability to learn and adapt and achieve true autonomy. Robotics becomes truly powerful when sensing, action, and intelligence come all together, just like we discussed today. When a robot can sense what is around it, it makes um, smart decisions and then act on it. Uh, it becomes a very useful and reliable machine. When we see in our real life, for example, in a robot vacuum that detects obstacles and changes the direction, and in a drone that keeps itself stable in the air by reading sensor information 1,000 times in a second. Although today we focus mainly on how robots understand and interact with their environment, there are still a lot of things happening behind the scene. Modern robots use advanced electronics, tiny MEMS sensors, machine learning models, and fast uh, control loops to work smoothly and, of course, safely. All these hidden technologies play a huge role in making robotics more intelligent and more capable every year. As we continue to explore, we'll see uh, that every concept we discussed today um, connects every big idea, even bigger ideas. For example, autonomous driving, medical robots, those perform precise surgery, or industrial robots that learn with their experiences and improve their performance over time. I hope today's session gives you a strong and confident foundation and also inspire you um, to learn more, experience more, and stay curious about the technology, what is coming next, especially in robotics. With these words, I would say good luck for your future. Thank you.